In this video, we're going to have a crash course on linear equations. You need linear equations to do regression analysis in our regression and correlation chapter. And so this is a video that will help remind you of what a linear equation is. So if you've taken an algebra class before, you've probably been introduced to a linear equation in slope-intercept form. Y equals mx plus b is a linear equation in slope-intercept form. M represents the slope of the line, so that is a measurement of how quickly a line rises or falls when we look at the line from left to right. And B represents the y-coordinate of the y-intercept. Let's draw a picture. So every linear equation that we draw is a line, and a line is made up of an infinite amount of points. So every point on this line has coordinates x, y. The y-intercept of this equation is this point right here. Its coordinates are 0 for x and whatever the y value is. So maybe that's at like 3, or maybe it's at 100. Just some y value. The slope of the line is the measurement from any 2 points on the line when we count how many units do we rise or go in the vertical direction versus how many units do we run, do we go in the horizontal direction. So those 2 dotted lines there, we can think of the vertical component as the change in y, and we can think of the horizontal component as the change in x. So when we measure slope, which is the letter m, we are taking the ratio of the change in y. So in other words, how many units does it take to get from this point to this point, how many y units, divided by the change in x. So how many x units does it take to get from this point to this point? So you maybe have heard the phrase rise over run. So slope is always the quotient of the vertical, the rise or fall, divided by the run, the horizontal movement. So there actually is a formula for slope. So if we say that these points here, let's call this point x1, y1, and we'll call this point here x2, y2, the way that we measure that is by taking the difference in the y's and dividing by the difference in the x's. So in summary, the equation of this line is mx plus b. The m represents how steeply this line rises because this is an uphill line. The b is the y-intercept. So really this point right here is 0b. The y value for this coordinate here is b. And this is a line with a positive slope because it goes uphill. If m was less than 0, we would have a negative slope and the line would go downhill. Let's do an example with some numbers. Let's go ahead and graph the line y equals negative 2/3 x plus 5. So first realize here that the slope is negative 2/3. So my rise is 2 units and my run is 3 units. And it's negative, so that means that this is a downhill line. The other piece of information I have here is the 5, and so that means that my y-intercept is the point 0, 5. So when we're graphing linear equations and we are given a line in mx plus b format, slope-intercept format, we start with the y-intercept. So that's the 5 right there, 0, 5. And now from that point, we use the rise and run of the slope to find subsequent points. So if I rise 2 units, I want to run 3 units, but I want to run to the left because I want this line to be downhill. So I'm going to rise 1, 2 units, and then I'm going to run 1, 2, 3 units. And so this point is on the line. If I go back to the y-intercept and instead of rising 2 units, suppose I fall 2 units, then I want to run 3 units to the right, again, so that when I connect these points, I end up with a downhill line, right? I end up with this line going in the downhill direction. And I can continue this process as many times as I want, this rise 2, run 3, to get as many points as I need in order to graph the line as accurately as possible. Let's talk a little bit more about this interpretation of the slope. So we've used these whole numbers 2 and 3 to get from one point to a next. For every time we change 2 units in the y direction, we change 3 units in the x direction. Or conversely, we can say, for every time we change 3 units in the x direction, we change 2 units in the y direction. What if we wanted to talk about this change as a unit? So instead of 2 or 3 units, what if we just want to talk about 1 unit? Let's zoom in. So instead of talking about changing 3 units in the x direction and 2 units in the y direction, let's go ahead and fix our x at 1 unit. So if we start at this point here that we know is on the line, and I go 1 unit in the x direction, what is this vertical movement right here? I know it's really hard to see, but I'm asking, how big is this line right there? Well, for every 1 unit I move for x, this distance to this distance right there is 2/3. This right here is 2/3. And where did we see 2/3? Well, that is the slope of the line. So another way of interpreting slope in terms of 1 unit in x is for every 1 unit that x changes, then y will change by the value of m. So for every 1 unit change in x, the value of y changes by m. In this example, m is 2/3. So for every 1 unit that we change in x, y changes by 2/3. And we can see that anywhere on this line. If I start at this point here and I go 1 unit in the x direction, either left or right, it doesn't matter. The value of y is going up or down by 2/3 of a unit. So again, 1 unit this way, 2/3 of a unit in the y direction. 1 unit this way, 2/3 of a unit in the y direction. 1 unit, 2/3 in the y direction. That's how we can interpret slope. Let's look at a real-world example of the meaning of slope and a linear equation. So let's consider that the value of a car over time is a linear function. It probably isn't linear, but let's just pretend that it is. So over time means that my x-axis, my horizontal axis, represents time. So my x values are time values, and my y-axis represents money, or the value of the car. And so time here will be measured in years, and the value of the car will be measured in dollars. So when time is 0, how much is your car worth? Well, that's how much you bought the car for. So let's say that you bought the car for $20,000. So when time is 0, the car is worth $20,000. That is the y-intercept of our linear equation. And then we know that this car depreciates over time. So again, assuming here that we have this linear slope, the value of the car, the longer you own it, decreases over time until eventually the value of the car reaches 0. So when the value of the car reaches 0, we actually have the X-intercept. And so let's just throw out a number here. Let's say that it takes 15 years for the value of the car to reach 0. So all of these points on this line represent the value of your car a certain number of years after you've owned it. So, maybe after you've owned it 1 year, so if x is 1 here, what would the value of your car be after 1 year? So in order to find any of the y values for each of these points here, we need to know what the equation of this line is. We already have the y-intercept. Let's go ahead and calculate the slope of the line. So the slope of the line can be calculated using any 2 points. And all we have to do with those 2 points is take the difference in the y values and divide by the difference in the x values. So here are 2 points, our x and y intercepts. So we'll take 20,000 minus 0. So that's from using this point and this point. So 20,000 minus 0, the difference in the y's, divided by the difference in the x's. So the x value that goes with 20,000 is 0, and the x value that goes with the 0, y value is 15. So again, that's this 0 minus this 15. And so what we see is that the slope here is 20,000 divided by negative 15. So our slope is negative, which should make sense because this is a downhill line. And let me just go ahead and clean this value up. You can reduce this to negative 4,000 over 3, but as a decimal, and to think about it in terms of money here, this is approximately negative $1,333.33. So the equation of my line is y equals negative 1,333.33x plus the y-intercept, which is 20,000. So this is the equation of my line. So how can we interpret this slope value here using what we learned on the previous page? So for every 1 unit change in x, y changes by this amount. So now thinking about the context of the problem here, what does 1 unit in x mean? Well, to go from here to here, if this is 1 unit in x, this represents 1 year. So for every 1 unit change in x, so to go from here to here, what is this y value right here? That y value would be $1,333.33. So for every year we own the car is depreciating by a monetary value of $1,333.33. Now let's think about how do we use this regression equation, this linear equation, to find these y values that I asked for right here. So in other words, when x is 1, what is y? So in order to answer a question like that, all we have to do is we just have to plug in the given x value. So if I plug in 1 for x, I can just use my calculator to get the y value. So after 1 year, the car is worth $18,666.67. Right? So after 1 year, it depreciated by that 1,333 number, and that gives us a value of $18,666.67. We could similarly ask, what is the car worth after 12 years? So when x is 12, what is this y value? Well, if I plug in that x value of 12 into my linear equation, so I'm plugging it in for x right here. Again, just using my calculator here, I'll plug in negative 1,333.33 times 12, and then I'll add 20,000, and I get $4,004.04. So after you've owned the car for 12 years, it's only worth $4,000. So this is a good example of a linear equation and how you use the equation of this line to answer real-world questions. And we'll be translating these ideas into our next section of correlation and regression.